this video, we are going to discuss the problem stepping numbers. So first let's discuss the problem statement. What the problem is saying. So problem is saying that we are given with a number which is called a stepping number if all the adjacent digits have an absolute difference of 1, that is 3 to 1, you can see this is a stepping number. Okay, while 4 to 1 is not a stepping number because after 4 we have a 2. We have to find all the stepping numbers which are present between n and n. We don't have to print the numbers. We have to just count that how many stepping numbers are basically there in this given range. You can see the example between 0 to 21. We have only one stepping number which is 13. So this is what we have to do. Now let's see how we can solve this particular problem. So guys, we all know. Let's say that x is our stepping number. Let's say x is our stepping number. Let's say for the first digit of x, the first digit of x is 3. The first digit of x is 3. So there will be possibility of only two possibilities are there for the second digit. Only two possibilities are there. Just understand what I am saying, okay? For the second digit, there are only two possibilities. Either the second digit can be 4, that is 3 plus 1, and the second digit can be 5, that is, sorry, not 5, 2. 2, that is 3 minus 1. Means, let's say if I have written 3, 4, 3. This is a stepping number, you can see. Why? Because after 3, we have a digit which is 1 greater than 3. Then we have a digit which is 1 less than 4. Similarly, 3, 2, 1, 6, 5, 4, 7, 8, 7. Okay, so these all the numbers are stepping number because the difference between the digits are either plus 1 or minus 1. So means if our first digit is 3, our next digit will surely either 4 or just either 2. 1 greater than 3 or 1 less than 3. Okay, similarly, let's say if our first digit is 3, so then we will have 4 and 2, which is plus 1 and minus 1 of this digit. After that again, so this is a one digit number which is 3. This is also a stepping number. Similarly, we have created two more numbers, which is 34 and 32. You can see 3 and 4, 3 and 4, and 3 and 2 are also the numbers. Similarly, if we again move on, plus 1 here it will be 5 and minus 1 here it will be 3. Similarly, here it will be plus 1, 3, here it will be minus 1, 1. These are all our numbers. These are all our also stepping numbers. You can see 3, 4, 5, 3, 4, 3, 3, 2, 3, and 3, 2, 1. These all are also stepping numbers. This is how we can find. You can see in this way all the stepping numbers which are whose first digit is 3. All the stepping number whose first digit is 3 can be formed, can be easily formed. And similarly, then again we can have 6 and 4. Here we can have 4 and 2. Here we can have 4 and 2. And then you can see for this one, we can have a plus 1 case, but we can have a minus 1 case. Similarly, if we have a digit, let's say x in general, if we will say, so we can have a digit x plus 1, the next digit, and x minus. If this is a digit, the next digit can be x plus 1 or x minus. This will be the next digit of a number. I hope this is clear. There are two corner cases. Let's also understand them. If our current digit is 9, so we can not have plus 1 case. We can only have minus 1 case. Because if there is a 9, the next digit can only be 8. It cannot be 10 because 10 is not a single digit number. So after 9, we can only have 8. We cannot have 10 or 0. Otherwise, it will be wrong. Similarly, for 0, we can only have plus 1 case. That is 1. We cannot have minus 1. After 1, we can only have 1. Or that's the only case. You can see here. If this is a stepping number. This is not a stepping number. Minus cannot be there. Similarly, this is a stepping number. But this is not a stepping number. These are the two corner cases that we have to handle. You can see that this is somehow like a tree or a graph we can see. This is somehow like a graph, and that is what we will do. What we will do, we will create a graph. We will create a graph, and then we will perform the breadth first search. Means concept similar to breadth first search, DFS. Sorry, depth first. Sorry, not breadth first. Depth first search. Because you will see depth first search is going on. Depth first. Depth first. Depth. And then when we reach the end, we will get the number, which is 3, 4, 3, 4. This is how we can just get the number. Starting from root to leaf, a number is there, which is a stepping number, which is a stepping number. Okay? So this is what we have to do. We can apply breadth first search. So for DFS, we all know that for this particular algorithm of DFS, we use Q. Or basically, oh sorry, for DFS we use stack, but here we will apply something similar to BFS also, which is breadth first search. Why breadth first search? Because first of all, what we will do, for each number of tree, we will check its, so let me again write, for each number of tree, we will check first its tiles. It will be something of BFS approach we will be going. And that is why we will be using Q. Okay. Let's see how we will do. So let's say that the number, the range of number which we are having is from 0 to let's say 100. Means you have to find the numbers, stepping numbers which are between 0 and 100. So first of all, what we will do, we will check for each and every stepping number which is starting from, which is between 0 and 100. So first of all, let's discuss stepping numbers which are starting from 0. So stepping number whose first digit is 0 will be 0 only. Will be 0 only. So whenever we encounter a number which is 0, we will end it. That yeah, there is a one number who is starting with 0. That is the only stepping number which is starting with 0. Because if we write 0, 1, that is 1 only. So that we will not consider trailing zeros. Okay. Now let's find numbers which are starting from 1. So for 1 we have 1. We can also have 12 and 10. So 1 will lead to 12 and 10. But now we cannot go. Now we can, because here it will be 1, 0, 1, and here it will be 1, 2, 1, and 1, 2, 3. That is out of our range. Our range is still 100 only. Our range is still 100 only. Okay? Our range is still 100 only. Now, for 2 also, we can have the different numbers 23 and 21. For 3 also, we can have 34 and 32. Similarly, for 4 also, we will have two numbers. For 5 also, we will have two such numbers. For 6 also. For 7 also. For 8 also. Let's write it. For 9, as I told you, we can have 98. We cannot have the plus 1. So basically 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 2, 16, and plus 1 for the 0, and plus 1 for this 98. And obviously these all 9 numbers are also there. So this will be the answer. This is the something which you have to find. So what we will do is, guys, we will check for stepping numbers which are starting from each and every digit from 0 to 9. From 0 to 9. We'll check for each and every stepping number which is starting from 0 to 9. Okay. Let's see how we can solve this particular problem. Let's see this thing. How we can solve this particular problem. So what it will do is, guys, at first let's say we have a queue. In this queue, what it will do? It will first insert this one. So one is inserted. Okay. After one is inserted, it will pull out this one. It will consider that one too. So it will increase the count, and then it will add a digit greater than 1 after it and digit less than it after it. Again, it will push back into a queue. Now, similarly for 12 also, it will check for its other number. So this is how the BFS works. That is breadth first search. Breadth first search is going on. Okay. So first, let's move towards the code part to understand how we are exactly going to do. Okay. And let's first write the BFS function for our particular program. Okay. So guys, see here, what we will do here is that we will have n and m. That is nothing but the range. That is nothing but the range of our means where we have to find for the stepping number. So we will have in BFS, okay, And we will have this range, check that we are at the correct place, and the number num. The number num is our current number. The number num is our current number. And as we know that we will call this particular function BFS, we will call this particular function BFS for all the numbers starting from 0 till 9. 0 till 9. We'll call this number BFS. Okay. Why? Because this number is called because we will check for each and every digit that all the stepping numbers are starting from 0, all the stepping numbers which are starting from 1, from 2, from 3 for this given range, the range which is given to you. We will check for each and every number which is starting from a particular digit and which is in this particular range. So we'll call this BFF function because what is this I? What is this num? This num is basically the first digit of a stepping number. The first digit can be anything. It can be 0 also, it can be 9 also. The first digit can be all the numbers. And when we will get the first digit, let's say if I have told you that first digit of your number is x, you can easily find. The next digit can be x plus 1 and x minus 1. Similarly, next digit can be plus 1 minus 1. If the first digit is, let's say, 5, you can easily see that the second digit can be either 4, either 6. It can be either 3, either 5, either 7, either 5. This is what you can do. The first digit is basically the thing. If you don't know the first digit, you can find the next digits which can be made because after 5 we can only have 4 or 6, then only it can be a stepping number. After 4 we can only have 5 or 3. We know this thing. Okay, so this is what basically is done here. What we will do, as we have told, we will have this first digit. This num is basically the first digit of our stepping number. And this we will check for each and every number. Means all the stepping numbers which are starting from 0, 1, 2, 3. So this will range for all the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now what we will do here, as we do in PFS, first of all we will have a count. This count will basically count how many stepping numbers are there. So count number of stepping numbers. Okay. So now we will have a queue as we have. So we're just using the queue. Okay. Now we will have a while loop and we will run until this queue will be empty. Till then, this while loop will be run. Okay, will be there. Now guys, now what we have, as I told you, it will just insert the numbers in the queue. Let's say we are searching for, let's say our first digit is 4. So first it will insert 4 in the queue. Okay? So let's insert it. Let's insert a queue in the queue. Let's insert. Okay. So means basically we have to insert this here only for the first. Let's push it in the queue, which is now. Okay. After inserting, what it will do, it will extract that front number. The front number will be extracted. This is the front now. This is the front of the queue. From here, it will be pushed. From back, it will be pushed and extracted from the front. What I will do, I will simply take a number. Let's call it stepping number, step number, and we will make it is equal to q dot front. Okay. Now we will pop that number. That number 5, that number 4 is not present. Let's pop it. Okay. We are just dry learning while writing the code. Okay. So now currently we don't have anything in our queue. It is empty. And we have our 5 in our step number. We have our step number called 5. Now guys, this step number can be of, so first of all what we will do, we'll check whether this step number is in our range or not. Is in our range or not. What we want? We want that this is our step number. This should be greater than equal to n and this should be less than equal to n. That is what we want. That is the range of our number. No? That is a range. If it is the case, we will simply increase the count which we have taken. That yeah, we have got a stepping number. But there also a case else if our stepping number is greater than n. Okay, or one more thing is there. Or our stepping number, or you can say our num only. This num. If this num is zero, Why I'm saying this thing? Why I'm saying this thing? Because I'm saying this thing because for you can say because for zero we only have one stepping number. We cannot have anything else. If you will say 0, 1, 2, 0, 1, 2 is basically similar to 1, 2. We will consider 1, 2. We will not consider 0, 1, 2. We will not have trailing zero. So we will continue. Okay, we will continue. Now, if these both the conditions are not there, so what we will do? Because we want, let's say if we are given with a number, okay, let's say our current step number is 27. So we have to focus on not it cannot be 27. Okay, let's say it is 54. So we don't have to focus on the starting digit. We just focus on the last digit. Because based on the last digit, the next digit will be there. If last digit is 4, so we know the next digit can be either 3 or either 5. So based on his last digit, everything happens. So currently in our question we have 5. So 5 is the last digit. We will store this last digit, okay? We'll find this last digit like this as a modulo of 10. Now, as I told you, based on that last digit, let's say our current number is 54. We have counted its last digit. So what can be the next number? The next numbers can be either 54 and 3, either 54 or 5. These are the last numbers. Basically, if current number is x, it will be x into 10 plus last digit plus 1, or basically x into 10 plus last digit minus 1. You can see here for 54 number was x and last digit was 4. The last digit plus 1 was 5, minus 1 was 3. The next two numbers were 550 plus 5, 540 plus 3. So 545, 543 are the next two numbers. You can see these are the next two numbers that we can have. After 4, we can add up 5, we can add up 3. So we will take two numbers. Let's say step number A, that will be equal to step number into 10 plus, plus the last digit, okay, last digit minus. And we can have a step number B, which will be equal to similar to this, will be equal to last digit plus 1. But wait guys, wait. Before pushing it into the queue, what I told you, let's say our current number was 5. So for 5, we have got our next number. Because for 5, its last digit was also 5. So the two numbers, which is step num A and step num B, are now step num A is 50 and step num B is 56. That is what we have got. Now we have to push these numbers again into the queue. But there is a condition, there is a corner cases which we have discussed. That if our last digit is equal to 0, if our last digit is equal to 0, in that case we cannot have this particular case of minus 1. In that case we'll only push step num B. In that case we will only push step num or not equal to 0. If it is or you can say one thing, we can write it like this: if it is not equal to 0, so means if our last digit is not equal to 0, then only we can push step num A. Getting? If it is not equal to 0, then only we can push this particular thing. And similarly, if the last digit is not equal to 9, so in that case we will push this particular number, which is step number B. Because if last digit is 9, so we should not have pushed this last digit. It will not be the case that we have already discussed. Okay? And after this particular case, what we will do? We will simply have out of the loop. So this is what this while loop will run. After this while loop, what I will do? I will just return my count. And this count will be here. So this store, let's add this count. Let's have an answer here. And this answer will store the complete count for all the BFS, for all the calls of this BFF function, for all the calls of this BFF. And then I will simply return this answer. This was the complete function, complete BFS function that we have written. Let's compile it. So you can see that for this 53 and 56, this 53 and 56 will again post into the queue. Again, the 53 will be checked. And the number residing 56 will be there, 53 2 and 53 4. Again, this will be pushed here. So this cycle will go on, go on, go on until numbers which is out of the range come. If a number in the range comes, it will basically, it will just, it will just be my song. If a number in the range comes, it will increase the count. And if a number out of the range comes, it will continue. That will be the case. Here you can see that we have got the right output. Let's submit the code. Let's see how we have done run. So here you can see that we have got the right answer. We have got the exactly right answer for this particular code. If we talk about the time complexity, okay, and the space complexity, so you can see that this particular, we are doing this particular BFS approach, okay, and the BFS approach is going up to the while loop, okay, and how many times this BFS approach is running till the queue will be empty, okay. So till the queue will be empty, this particular BFS approach is basically done. If we talk about how the time complexity and space complexity is basically working, we talk about how this particular space complexity and time complexity is working. So we can also have the DFS based approach. We should also have a DFS based approach. But what we have done, we have discussed the BFS based solution. There are both the solutions. It can be DFS based also. It can be BFS based also. Both the uh, both the approaches are basically given here. Okay. So this is what we have to do. Okay. If we talk about the space complexity, so this is the queue. That is the extra space we are taking. This queue is taking the extra space. And it is basically equal to the range of the numbers. The expector is written. It is equal to range of the numbers. The range, whatever is the range from n to m, because that is the worst case. This stack will store. Because if it is not the case, it will just continue. And if we talk about it, the time complexity thing. If we talk about a time complexity thing, you can see that this while loop is basically checking for each and every node. This while loop is basically checking each and every node of a particular number. And it is running n times. This is 10 times. This is basically constant. Whatever is the time complexity of the BFS function, that will be our answer. And it will be also log of n as it is written. And that is what we are going to do. That is what we are going to discuss here. Okay. So this is how we have discussed this particular problem. If you have liked the approach, okay, please hit the like button. If you have any doubt, please comment down. Please share this with your friends and please subscribe this amazing channel for this amazing content. Thank you very much. Thank you.